Good morning. The title of the topic is Overview of Business Intelligence and Role of Data Warehousing in Business Intelligence. Outline of the lecture is as follows. First, we discuss what is business intelligence and why is it popular. Then we also discuss various business intelligence steps, life cycle of business intelligence, example scenarios, current state of business intelligence, what are the different tools exist today for BI, role of data warehousing in BI, characteristics of data in data warehouse. A popular quote given by Aristotle is, "The secret of business is to know something that nobody else knows." The course BI helps to identify such secrets. Most of the organizations today are faced with an almost overwhelming and demand-oriented set of questions. The slide shows some of the demand-oriented set of questions. What is the effectiveness of various government programs, which is a demand-oriented question, and its cost? What is the breakdown of the client base by program, by service, or by demographic makeup? What is the adherence of the programs to state-wise with respect to regulations? What are the administrative costs of running district, state, and region-based programs? And so on. So these are the current demand-oriented questions which we cannot answer using by traditional database power. The slide shows the data versus over a period of time, how data is growing. If you carefully view the graph shown on the slide, much of the data to answer these questions exists and more is available, but there is a growing gap present in the ability of organizations to analyze it. So that means to say, during late 60s, there are no analytical questions. But today, because of large availability of the data, there are a lot of demand-oriented questions, which we cannot answer using traditional database power. That means to say, to satisfy the current user requirements, we need a set of methods, technology, and tools to support in answering such demand-oriented questions. So what are the challenges for data access to answer these so-called demand-oriented questions? Ultimately, to answer such questions, you need to access the data. So accessing the data is also becoming difficult, and it takes enormous amount of time due to large sizes of data. So one challenge is multiple sources of data and reporting systems, difficulty in locating and addressing information, unreliable information, pressures to lower costs and improve services, information requests take days or weeks to fulfill, rekeyed data ensuring errors creep into results. So in order to answer demand-oriented questions, there are different kinds of challenges which we need to take into account while accessing the data. So for example, nowadays customers are interested in not spending more money, but they want better service. So we have to reduce the cost of performing a service. That means how do we improve the service is also important. And another challenge is, whenever you pose a request, the request must be processed and the related answer must be provided very quickly. Due to multiple sources of data and reporting systems, to answer such demand-oriented requests, may take a lot of time because we need to access data from various systems. That is another challenge. And similarly, another difficulty is where the data is available and how it is represented, location of the sources, and identifying the right information is also another challenge. So to tackle these type of challenges, in order to answer more demand-oriented questions, there is a technology currently available with us, which we call as BI technology. The techniques of business intelligence are useful to answer these questions. Business intelligence involves the gathering, management, and analysis of data for the purpose of turning the data into useful information, which is then used to improve decision making. Organizations can then make more strategic decisions about how to administer clients and programs. These practices can also reduce the operating costs through more effective financial analysis, risk management, and fraud management. So that is to say, BI is basically helps to utilize your data assets for better decision making. In other words, we can also say BI is able to turn the data into useful information. It assists to take more strategic decisions, and at the same time it minimizes the operating cost. So there is a fundamental shift in the purpose, objective, and the use of information. The slide shows three different kinds of systems. One is the accounting system, middle one is the operation systems, and the last one is the intelligence systems. Accounting systems basically uses sort and report, administrative and accounting systems to automate financial reporting processes. If you see the third one, intelligence system, the intelligence systems discover and analysis systems used to enhance strategic and tactical decisions. So these are the current generation systems. Business intelligence system belongs to this category. So the purpose of using each system is different in each category here. Objective is different. The way the data is used is also different. So therefore BI provides different kinds of solutions. There are 4 different kinds of solutions displayed on the slide. BI solutions enables an end user to quickly and easily analyze organizational data to make intelligent decisions. Business intelligence systems puts the information in the hands of end users. BI is the combination of data warehouse and end user data access and analysis tools. BI solution is an investment in information technology that can assist governments in managing limited fiscal resources. There are different stages. In stage 1, we use the concept of data warehouse and data mart to build the repository. Stage 2 applies some statistical methods and multidimensional modeling, data mining, optimization. They're all proceed later. The value of information which we discover from BI is very useful for the decision makers. So in fact, these are all different kinds of techniques. In this course, we study only the fundamental concepts of data warehouses and multidimensional modeling. Industry leaders agree that data warehousing is a process, a journey, and it takes a commitment. The slide shows different kinds of messages given by popular groups. For example, the Meta group says data warehousing is a process, it is not a place. Whereas a popular data warehousing institute states that data warehousing is a journey, not a destination. Gartner Group states that a data warehouse is an architecture, not a product. Computer World states that you can't buy a data warehouse, you have to build it. So these are the different kinds of messages given by these popular groups and the institutes. So what is BI? Business intelligence is a software system. Basically, it allows companies to make more informed and faster decisions by helping the organizations to access and analyze the data. It is a relatively new term, but it is synonymous with a range of applications that have been around for years. That means BI is nothing but an umbrella term that combines architectures, tools, databases, applications, and methodologies by building a system which basically assists the organizations to make more informed and faster decisions. Now we give different kinds of definitions provided by the leaders. Business intelligence is the process of transforming data into information, and through discovery transforming that information into knowledge. That means it is the conversion of data into information in such a way that the business is able to analyze the information to gain insight and take a decision. That means a lot of analysis is involved here to get insight in order to take an action. Sometimes it is also used synonymously with the information available in an enterprise for making strategic decisions. That is to say, it is a discipline of developing information that is conclusive, fact-based, and actionable. So in order to build such a system, we need a mechanism to store this conclusive, fact-based, and actionable data. What is the data required to get this kind of results? So such data only must be pushed into the data warehouse. The slide shows how BI evolved. If you observe the slide, business intelligence requires a lot of techniques and technologies. So it uses data warehouses, data marts, and it also requires some broadcasting tools. It also requires some portals, a decision support system, spreadsheets, Excel sheets, financial reporting, OLAP, digital cockpits, scorecards and dashboards, etc. So they are all integrated here in the form of a software called BI. Now let us see why is it popular. Different kinds of descriptions are taken into account here. BI systems helpful to answer what if questions. What if questions in the sense why it has happened, when it has happened, what to do, what to happen, what not to happen, how it has happened. They are all different questions, right? So it is a part of a decision making support system. Forecasting is possible. Human sized reports also can be represented very easily here using the power of BI. So human sized reports means the size of the report varies with respect to the level of the person. When higher level person wants to view the report, he will see the report only precise and consolidated manner. Whereas the low level person may be interested in seeing the report at minute level, detailed report. So depending on the level of the person, the size of the report varies. So such reports are called human sized reports. So every company in fact has a tons of data, but there is no real knowledge. So how you gather the data, how you manage the data, how you use the information is going to determine whether you are going to win or lose. So in the sense that how quickly you gather, how quickly you manage, and how quickly you use the information is very important here. In fact, this is one of the popular messages given by Bill Gates. Various steps of business intelligence are shown on the slide. The first step is gathering data, then organization and storing data, then data analysis, then dissemination of results, and then finally decision making and action. So every BI system follows these steps in providing BI solutions. The life cycle of BI is shown here on the slide. Measurement, analysis, insight, and action are the four phases of BI. So first you are measuring the data. So what kind of data needs to be considered for your analysis? That must be measured first. Then do the analysis, then get insight, and then take action. So that is why this is called actionable data. Actionable data only must be incorporated in the data warehouse. Let us take an example scenario. Suppose a branch manager wants to take a decision how much he should keep the cash in his bank to operate the next day without any difficulty. So if you see the slide, a local branch manager views a report generated by a database application at the end of a work day and decides to order more cash from the central bank. Why he has to order more cash? Due to the low level of cash in the local branch as per the report. So that means the manager has taken a decision of ordering more cash from the central bank to his bank. So how the decision was taken? The decision was taken based on the data about the cash available and then related to the various steps of BI only here. The data about cash was gathered and organized in a database, analyzed into a report, and then that report was submitted to the manager. Then he make a decision based on the report. So what is the meaning of here data about the cash was gathered? That means every day branch performs certain operations, right? Credit and debits, etc. So the total summary of all the transactions made across different kinds of accounts the bank is operating, they are all computed, the total credits, total debits, etc. Then difference is taken and then a report is submitted. Then by seeing the balance available in the bank on that day, at the end of the business working day, the manager takes a decision to order more cash. So if you observe all four steps of BI, you can see in this scenario: gathering, then organization, then analysis, then dissemination, then decision making. So all these steps, even though it is a simple example, all these steps are used here every day by the manager. Let us take another example scenario. A CEO of a bank wants to decide to find out top branches. Okay? So a CEO of a large bank views a comprehensive analysis report describing the performance of each branch for the past 10 years. That means how each branch has performed every year. Past 10 years performance of each branch is prepared in the form of a comprehensive report. A decision to close a particular bank depends on the performance only. So therefore, the manager, CEO, makes a decision to close a particular branch. then how he is taking a decision. So the data about branches was gathered. So here the data about the branches was gathered means not the day-to-day transactions or day-to-day operations of the bank. Okay, maybe monthly or quarterly or yearly the performance indicators are calculated based on some formula. Right? The data about branches was gathered and organized in a database, analyzed into a report that was disseminated to the CEO, who then made a decision based on it. So in this scenario also, gathering, organization, storing, analysis, dissemination and decision making all are involved here. As I mentioned earlier, BI is always helps to answer demand oriented questions. What happened? For example, what were total sales this month? What's happening? Are our sales going up or down? That means to see the trend analysis, you can ask what's happening. Why it has happened? Why the sales have gone down? Reasons for happening is again a question. Right? What will happen? Forecasting. Then what do I want to do happen? Planning. You have to meet the targets. If you want to meet the target, you have to plan. Right? So these are called demand oriented questions. Such questions can be answered very easily using BI. BI can be applied within the business or in those areas that reach outside the business. Few examples are shown on the slide. Companies spend millions on ERP and find they are unable to report or analysis their data. In that situation, BI is more useful. Balanced scorecards provides a consolidation view of the business. Segmentation is basically used to cut the data by the key dimension. Risk management, activity planning, campaigning, etc. They are all applications where we can use BI. Key performance indicators tracking is also possible. Sales analysis, sales forecasting, etc. The architecture of business intelligence consists of three components. They are data warehouse component, business analytics component, performance management component. In this we discuss only the data warehouse component. So what is the need of data warehousing? Then already I discussed earlier, data warehousing is used to provide an integrated company-wide view of high quality information. Operational and analytical systems are separated and it is a foundation of a comprehensive business intelligence system. BI software basically integrates the different technological powers. It uses relational database technology along with OLAP, multidimensional technology and web technology. And also the software is scalable for storing the data in the form of a data warehouse and flexible. Performance is good. Business views are many business views you can derive from the data warehouse. And the software is web deployable also. That means web-based BI solutions can also be provided by using web technology. From the tools point of view, business intelligence software enables business users to see and use large amounts of complex data. Tools are categorized into different parts. Some tools are required in each category. First category of tools are database related software tools, DBMS, query writing, query tools, reporting tools. Then data warehouse related tools are data warehouse creation and data mart creation, etc. OLAP tools also belong to the data warehouse related tools. Then data mining related tools And also we require other special purpose tools for loading of the data, backup, etc. So whenever you want to provide a BI solution, you need to integrate the functionality of all these tools together. So to know how the business is really doing, we need to use this technology. So if you see the slide, the key benefits of building a data warehouse and using OLAP are very fast, flexible, and all potential queries available. And also it offloads queries from production systems. It provides consistent data model. They are the advantages of data warehousing. If you observe the slide, the different kinds of source systems are custom application system, packaged application system, ERP, client data, etc. So all the data is integrated here in the form of a data warehouse. Then the executives, managers, and business analysts can access the required business data very quickly, and it provides flexibility. They can take subportion, they can take a portion of the data warehouse. They need not use the entire data warehouse to provide a business intelligence for a particular segment, right? And also it offloads queries from production systems. Whenever a query is posed by business manager, if data warehouse is not there, then in order to answer his request, you have to go through all the sections, all the systems. So it requires more time and more processing. To avoid that, and in order to provide a quick and timely results, we are building the data warehouse here, and provides a consistent data model. So the model is consistent. Your dimension modeling helps to decide how to build a data model, dimensional model. Once the data warehouse is built, then I can build data cubes for a portion of a data warehouse. So whenever data cubes are derived, then by using this data cube, you can provide the answers to the end user. Different kinds of OLAP operators like drill down, drill up, rotation, slicing, dicing. They are all different operators which are used to manipulate these cubes. So current state of business intelligence, it is robust, scalable, web deployable, technologies are available today. Problems are likely to lie in the data complexity, process, and people. Although the technology integrates data sources, the old problem still exists with the data quality and complexity, because a lot of commitment, as I mentioned, a lot of commitment is required from the people, and you have to define process very clearly. Successful implementation demands very close working between the business and the system providers. Choosing product is as odd as ever. There is no such thing as a greenfield site. Currently, ERP vendors are also offering solutions for BI. For example, SAP BW, SAP BI, they are all solutions on SAP database systems. What type of information BI should consider? BI should consider customer information, competitors information, business partners information, economic information, environmental information, and some internal information about the internal operations. This information is used to make effective and good quality business decisions. The slide shows some of the example tools, BI tools. This is a tool called MyAnalytics. So if you observe here in the background, there is a lot of processing needs to be done in order to show pictorially all these diagrams, and how the business is growing can be seen here. If something is shown in the red, means there is a danger zone, right? And something is shown in the green, means that segment market is good, right? Such kind of visual representations are very important for business people to take business decisions. So such a kind of solution you can provide using these type of tools. This is another tool called Clear. Here also different kinds of reports are shown for any activity. This is another tool powered by Crystal Portable Interactive Visual Model. Now we see the hierarchical structure of the data, how data is organized. At the lowest level we have data, known facts that can be recorded and stored on a computer media, which we call as raw facts. Then information, data processed into a form that has a meaning and useful. That means processed data is called information. Then knowledge is based on information and it implies responsibility and commitment to a decision. Then finally, decision ignites action based on the knowledge. Suppose if there is no tool, no BI is available, then the complexity of making a decision is very hard, is difficult, it takes more time. Imagine if the pyramid is collapsed, then whatever things you want to do, everything you have to do on the fly, which takes enormous amount of time, and in the process the business may slow down. So at one side, due to rapid development of technologies, data is growing at rapid rate, and at the same time users are expecting sophisticated information. How data is growing rapidly? You all know that automated collection tools are available today in the market, and there is a powerful technology, database technology, which leads to tremendous amounts of data stored in databases. But you are not able to satisfy the users when they demand something. So the solution is data warehousing, and OLAP provides set of methodologies to assist the decision makers to take better decisions. Data mining extracts the interesting knowledge. The knowledge is represented in the form of rules, regularities, patterns or constraints from data in large databases. So to satisfy the user's needs and demand, what we should do is we should uncover the hidden information. So data mining basically helps to uncover the hidden information. Characteristics of data. What are the characteristics of data in a data warehouse? Data warehouse is a database designed for analytical tasks using data from multiple applications. It supports small number of users with long interactions. If you see the database supports several users but with less interaction. But whereas here, data warehouse data supports small number of users and with long interactions. Usage wise, it is read intensive. Read intensive means no changes, right? Only reading of the data. Content is updated periodically. So updated means it is not just changing the value, you are only adding the data. So in that sense, content is periodically updated. Contains a few large tables. The data cardinality wise, data is very large, but number of tables are very small. Slide shows what are the users saying as far as data warehouse is concerned. Data should be integrated across the enterprise is the one view. Summary data has a real value to the organization. That means details data is not important. Summary data is more valuable from the organization point of view. Historical data holds the key to understanding data over time, and also what if capabilities are required. That means you should be able to answer the demand oriented questions. So therefore, a process of transforming data into information and making it available to users in a timely enough manner to make a difference is termed as a data warehouse. Benefits are, it provides access to a wide variety of data. Results can be represented in variety of formats, reports, graphs, etc. Data warehouse enhances the value of operational business applications. cost of product introduction comes down with target marketing campaigns, better decisions with lower cost, clear picture on asset and liability management, enterprise-wide purchasing and inventory patterns, and of course, using data warehouse we can maintain good relations with customers by knowing their requirements. And at the same time also we have certain limitations on the data warehouse. Basically data warehouse collects and report data that already exists. If an organization wishes to analyze the customers by zip code but addresses are not captured, then it is not possible to analyze. So that means you cannot create any additional data like databases here. If zip code is not there in databases, you can add a column and then insert zip codes. But in data warehouse, you cannot do that. Right? So therefore, what data is required for analysis must be available in operational systems. If they are not available, then you cannot do any analysis. And another limitation is, if quality of the data is poor, then decision will not be accurate decision. So data quality is very important here. While recording the data, if you are not able to maintain the quality properly, then if whatever the analysis you do, you get bad results. So when the results are bad, your decision may not be accurate, because you are going to take a decision based on the results. That's why additional data creation is not possible, and if poor quality of the data is there in the data warehouse, then your decisions are inaccurate. Risks. Risks are categorized into different levels here. Some risks are related to organizational risks. Risks can also be related to technological or project management or design risks. Risks relate to project team, always there, in the sense that suppose if somebody is trained and if he is a good project manager and if he leaves, then your project is going to close. In the middle of the project, if a project manager leaves and if there is no suitable trained people exist, then it is difficult to manage. So risks relate to project team. Entire project team may move from one organization to another organization. Then you have to close the project and then go. So it's a risk. Then technological risks. These risks relate to the planning, selection and use of warehousing technologies, poor scalability architectures, insufficient skills of implementers leads to a bad project outcome. Then project management risks, scale and scope of projects. Sometimes you may not define properly, then it leads to blame will go to the project management team only. So data and design risks, poor quality of data, unreliable data, improper collection of data. Then these three are related to design risks. Right? So therefore, if any of these things fails, then your data warehouse projects are going to fail. Now the reason for separations, why do we separate the data warehouse? The main reason for separating the data warehouse from the database is to enhance the performance. Operational databases designed and tuned for known transactions and known workloads. For example, if you have a railway reservation system, what are the transactions the railway reservation system every day does, you know, right? What is the workload also, you know. So they are designed and tuned for known transactions and known workloads. Complex OLAP queries would degrade performance for operational transactions. If the data warehouse is built, building a data cube and then performing operations on data cube are very fast. The same thing if you want to do it using without separation, then it degrades the performance because there is a lot of load on the system. And also special organization of the data, special type of access and implementation methods are required for multidimensional views and multidimensional queries, which are very important as far as the analysis is concerned. So in order to improve the performance in these scenarios, we need a separate data warehouse. Then second kind of reason for separation is functionality. Missing data, data consolidation, data quality aspects are very important as far as the functionality of the data is concerned. The reason is the decision support requires historical data which operational database systems do not typically maintain. Operational database history won't be maintained, right? So the data is missing in the operational system. Decision support requires consolidation of data from many heterogeneous sources. So heterogeneous sources are, some sources may be external sources and some may be operational sources. So therefore, whatever the data you take, you are not taking the data as it is and then putting in the data warehouse. You are only consolidating, aggregating, and then you are incorporating into the data warehouse. So data consolidation component takes enormous amount of time on the operational data. So you want to reduce the time to build that, process the queries by building the data warehouse. That's why data consolidation function is very important. As I already mentioned, different sources typically use inconsistent data representations, codes and formats which have to be reconciled. That means you have to bring into a unified format. Evolution of data warehouses. The slide shows what is the share of development in each category stage wise. Suppose if you observe the figure, in stage 1, which is a reporting stage, primarily major share goes to batch applications and very little ad hoc queries. Then when it goes to analyzing stage, there is an enormous amount of increase in ad hoc queries and little bit of analysis. Then third stage, predicting stage, which we call as analytical modeling, grows. So in the sense that continuous updates and short queries are added here. Operationalizing of data warehouse is nothing but continuous update and time sensitive queries become important. And if you go to the last stage, active data warehousing stage, where the event initiated actions take hold. So all these 5 components, batch, ad hoc, analysis, continuous update, short queries, event initiated actions, they are all part of active data warehousing. Equally shareable here. But if you see the previous stages, the initial stage of data warehousing is only reporting stage. Then second stage of data warehousing is analyzing stage. Then predicting the data warehouse size, operationalizing the data warehouse, then active data warehousing. So this way the data warehouse is evolved. Then in each stage the functioning is also stated here. What happened is related to reporting stage. Why did it happen? Analyzing stage. What will it happen? Predicting stage. What is happening? Operationalizing. Then making it happen. Active data warehouse. So this is how data warehouse was evolved over a period of time. Next topic is KDD process, knowledge discovery process. In this process, we have several stages. First, initial data is considered. Then by applying the selection process, we will identify the target data. Selection process basically obtains the data from various sources. Then once the target data is selected, then we will clean the data by applying the pre-processing techniques. Then when a pre-processing technique is applied on target data, we get pre-processed data. Then pre-processed data is converted to a common format by using transformation. So when we complete the transformation stage, we get a transformed data. On transformed data, we use data mining techniques for building models. Then the last stage is interpretation and evaluation stage, where we present the results to user in a meaningful manner. So that's ultimately your knowledge. Data mining is the core component in the knowledge discovery process. But to apply data mining, we need a data. So the entire portion of data cleaning and data integration methods are applied on different sources data to build a data warehouse. Once the data warehouse is built, then we can select the data by using selection process. Then we can apply data mining to identify the patterns, and then ultimately we get the knowledge. So application domain must be clearly identified first. Data selection creates a target data set. Data cleaning and data pre-processing generally is done in the staging area to clean the data. This process may take 60% of your effort. Data reduction and transformation determines useful features, dimensionality reduction, and invariant representations of the data. Then we choose functions of data mining like summarization, classification, regression, association, clustering, etc. Then we appropriately select a suitable mining algorithm. Then whenever you build a model using data mining methods, we will search for patterns of interest, and ultimately patterns are evaluated and knowledge is presented in a visual form by removing the redundant patterns, etc. So finally we get a discovered knowledge. So warehouse architecture is shown on the slide. There are different layers here: source data layer, data transformation layer, data warehouse layer, operations layer, reporting layer, metadata layer. Source data layer: any electronic repository of information that contains data of interest for management use or analytics can be considered as a source data layer. So all the data, these are all nothing but our sources. Then data transformation layer basically extracts data from the source locations and transforms it into the target format and structure. And the third one is the data warehouse layer, normally a relational database designed to hold large amounts of information for data analysis. So this is our data warehouse. Then reporting layer, BI tools, executive information systems, OLAP, and data mining applications are used in this layer. Then metadata layer informs about the operators, informs operators about data warehouse system status, and contains information about the data stored within, such as table and column names, descriptions, etc. Then operations layer, operations requiring loading, processing, and manipulating data from the data warehouse. It also covers the user management, security, and capacity restrictions as well. So if you observe, to build a data warehouse, we need to use the first three layers. To analyze the data and to apply data mining, then you should, means they are between the data warehouse layer and reporting layer. So what are the reporting tools? Different kinds of reporting tools are shown on the slide. BrioQuery, Business Objects, Impromptu, Focus for Windows, Discoverer 2000, etc. These are the reporting tools. Then warehouse related products. Warehouse related products are basically used to extract the data, clean the data, transform the data, refresh the data, etc. Computer Associates Ingress Replicator, Carlton Passport, SAS Access, Sybase Replication Layer, Platinum, Infor, Finer, etc. They all belong to warehouse related products. Then warehouse products are CA Ingress, Allbase SQL, Informix, SQL Server, Oracle's Red Brick Warehouse, SAS, AdaBoss, etc. They are all warehouse related products. Then warehouse server products, Oracle Warehouse Builder, Informix, Sybase belongs to the category of Oracle server products. Red Brick Warehouse, Teradata, IBM, DB2, Universal Server, etc. are also belong to the category of warehouse server products. These are some of the popular books. Building the Data Warehouse by Inman, then Managing the Data Warehouse again by Inman, Data Warehouse from Architecture to Implementation by Barry Devlin. These are some of the useful links. Data Warehouse Institute, OLAP Council, Larry Greensfield Data Warehouse Information Center, Rolf Kimball's homepage. So in this we get a lot of information related to the data warehouse.